We do have a very interesting topic today. Certainly it's the future of our industry, advanced air mobility. Our speakers today are Jim Viola, President and CEO of HAI. We also have Pete Bunce, the President and CEO of the General Aviation Manufacturers Association, joining us today. As always, we do encourage you to ask questions. If you do have questions, you would please type them into the question module that's in the control panel on the side of your screen. These questions are printed out. We will respond to the questions at the end of the webinar after both Pete and Jim have done their presentations. We do record these videos or these webinars. The video will be sent to you tomorrow within 24 hours. And they will also be available on the HAI webpage within about 24 hours as well. I'd now like to introduce Jim Viola and have him come on to introduce Pete Bunce.
All right, well, good afternoon, everyone. Glad you can join us today. It's a very exciting topic, and I certainly want to thank Pete Bunce for joining us this afternoon. When I first saw him give this presentation with RTCA, it was caught my attention, and I thought about, and I know we actually talked about this at Heli Expo back in January at Anaheim, which I'm talking about the advanced air mobility, which used to be the UAM, urban air mobility. But these vehicles are coming, and I want to make sure that you, as the members out here, are ready for what's coming down the pike. So Pete and I have a little bit of a similar background. He was an Air Force guy. I got out in 2005, and he went right over to industry. Of course, I got out of the Army in 2008, and I went to the FAA. But Pete has done a lot of great things. One of his favorite aircraft that I always thought, early days of the Army, that I might have an opportunity to fly and still would love to get in it is the A-10. So Pete always was supporting the ground troops. So as an Army guy, I certainly appreciate that. And then also in 2015, I got to work really close with Pete when we did the Arsenal of Democracy. And if you haven't seen some of the stuff that's on YouTube and everything about that, it's when Pete led an effort to get 50 warbirds to come down the river and fly over the mall. And so that was 70 years from World War II, and it was great demonstration. And I was really looking forward to the 75th this year, but everybody knows why that didn't happen. So Pete, welcome, and thank you for coming and talking to our membership about the future of the advanced air mobility.
Well, Jim, thank you for letting me be with you and Team HAI. We've always had a really close relationship develop between Matt and myself. And then last year, when we were together at Anaheim, I was so proud of the fact that you took over the association, and it's just a true pleasure to work with a fellow aviator and someone as passionate as you are toward our industry. Just a touch on, we had to cancel the Arsenal of Democracy flyover on May 8th, but we have been approved by all that you can't believe how many federal agencies to now do it on September 25th. So we're only a couple weeks out now. We've got over 60 World War II aircraft flying down through the prohibited airspace around the White House. We got permission signed off by the Secret Service to do that. So we aren't able to have a ceremony at the World War II Memorial, but we're still going to fly over the aircraft to honor the veterans who were just unfortunately losing so many of them right and left. So we're very proud to do that. But instead of talking about World War II aircraft from 75 years ago, today we'll talk about the future of advanced air mobility. And it's wonderful to have this opportunity to speak with the HAI crowd, because quite frankly, we need your help. There is so much to do. And we kicked this effort off back in about 5 years ago. And we originally had 18 companies that had petitioned us for membership. And unfortunately, the way the GAMA is set up, you had to have a certified product to be a member. But I went to the board and I talked to them about trying to provide a forum where we could have a different level of membership at a low dollar amount to be able to encourage a lot of these startup companies that wanted to get into, at that time, urban air mobility and electric propulsion, to be able to go ahead and get together and have them work on a common cause like the Gamma members do. You know, they put their competitive hats aside when they walk in the door, and it's just tremendous to be able to run an organization that has that cooperation and collaboration between its members. So we wanted to do the same thing for these companies that are doing that. So we started off around in the 18 range 5 years ago. Now it's 98 members. Virtually all the OEMs, the original equipment manufacturers for batteries, engines, avionics, and structure itself are part of the committee, because there's great business opportunity that's coming forward. And so what I'd like to do is talk to you about the landscape right now and give you a glimpse of what's happening. Next slide, please. If you look at the population of aircraft that are out there, just to level set everybody, if you look at the civil fleet out there, you can really tell, you know, pistons predominate, but there's about the same number of business jets as airlines, but rotorcraft right now dominate if you look at general aviation platforms as a single platform. Now, we all do consider unmanned aerial systems as general aviation. At last count, there was over 1.5 million just registered drones, for lack of a better term, in the U.S. Now, do we have advanced air mobility aircraft flying in the U.S. at this time, other than tests? No, but that landscape is going to change. And it's happened before. Dan, go to the next slide, please. If we look at the complexion of the fleet and why it's so important that we get this right here in North America, is look at the predominance of the fleet size. If you look at all of general aviation, and this doesn't include the drones, just look at the manned aircraft out there, over 63% is here in North America. And so we do want to get it right. And working with the FAA from the get-go and being able to use some of the standards mechanisms that I'll talk about here in a second, I think we're on a good path right now. And fortunately, I've got the luxury of being able to work with Jim, and Jim's old office at the FAA and the connections he has in the FAA helps facilitate our ability to get down into the bureaucracy within the FAA and be able to go and try to drive this new support and in some ways new levels of thinking about these vehicles. Next slide, Dan. So have we seen disruptive change before, and how quickly has it happened? Well, I love this slide. We created this a few years ago just to take a look at what Fifth Avenue in New York City looked like right at the turn of the last century, 1900. And what I've got circled there in the red circle is the one automobile on that street in 1900. Now, if you hit the next slide, Dan. Now let's take a look at basically 13 years later, same street. And if you hit it one more time, there is only one horse-drawn vehicle, horse-drawn buggy on that same street. So in 13 years, the world completely changed. And we've seen examples of that. Next slide, Dan. When we went and transitioned to being able to go to glass panel technology, and we started off with working with the Small Aircraft Directorate in Kansas City with the FAA. If you remember, some of the first systems came out, Garmin Amidine came out, and that revolution happened in even shorter than 13 years. It was about 8 years before virtually every aircraft offered glass. And the only reason that you wouldn't buy glass is if you wanted just to fly traditionally out there and like the lure of the steam gauges, as we call them. And we've seen that same transition in rotorcraft as well. So we have seen it in our lifetime, so this kind of change. But now let's look at some of these new vehicles that are out there. And note that some of them look like a rotorcraft, some of them look like a conventional aircraft, and some are a blend between. There are so many different designs and so many, the freedom and the opportunity to be able to work on these designs and be able to look at different propulsion methods. Obviously, physics takes predominance in being able to figure out what you're going to do, but each one of these designs is unique. And I'm gonna talk about a few of these to try to get us level set. So those of you that have been reading the trades, you saw that Pipistrel certified with EASA their small trainer, which looks like a conventional aircraft, except it's got batteries and it's got an electric motor. Think about the maintenance opportunity with electric motor. Your cycle time and everything that you have compared to a piston is just it's a maintenance dream from an owner's perspective to be able to have an electric motor, because 20,000 hour TBO is a lot different than we see with a piston engine. This has a potential to revolutionize training on the fixed wing side. And we're seeing the development of a trainer here with AIRSPACE in Colorado, and they're very deep into their certification program. Other aircraft that look like a conventional fixed wing aircraft, Aviation, which is an Israeli company, doing their development and certification with the FAA, and they're working both out of Seattle and Moses Lake right now, have electric propulsors on both wingtips and in the tail. And there's been some great development there that has happened, and their concept is regional aircraft transportation, whether it's at some of the hubs in the short haul up to a 500-mile range, or using the reliever and tertiary airports around the city to be able to provide that type of mobility. Then we've got all of the other designs that are out there right now. And what I think strikes people and really shocks them when we tell them that there are 6 companies that are very far and well along in their certification processes right now. We've had great cooperation, both with the FAA and EASA, and being able to develop the aircraft. One thing that we did back about 15 years ago is we started an effort on the fixed wing side that then ultimately will all migrate over to the rotorcraft side, at least on the Part 27 side, is the development of a capability to use internationally established standards. And the standards bodies that are out there, whether it's ASTM or EuroK or any of the standards bodies that we have, once we develop standards, it relieves the need to be able to go and continually do rulemaking. Now, the last time that the Part 23, before we had the recent Part 23 that used consensus standards incorporating it, it was over 25 years since the last time there was a modification of that regulation. So what did that result in? Well, we were having to do engine testing and actually trick the system through software changes to have it do things that it absolutely couldn't do when it was on the wing of an aircraft. But we had to trick the system to be able to pass an FAA test, because the standards, the regulation was so outdated. What advantage we have with standards is that when they're internationally recognized, you get engineers from all over the world working together with the engineers from the regulating authorities. They all sit in a room and they decide that this standard will be good. Now, that doesn't mean a company can not do something new and novel. But if they want to pick a structures component off the shelf or an electric engine module off the shelf and use it, they can use an internationally accepted standard. And what's neat about that is we can go and update those standards routinely so that the latest, greatest technology is incorporated into a revision of the standard. And we're working very closely with the standards bodies, but also FAA, EASA, Transport Canada, ANAC in Brazil, many of the world's leading authorities, to be able to go and start to fully utilize those standards. And it helps in really speeding the process towards certification and doing it using the most modern methods. And I ultimately believe strongly that it increases safety. If you look at a lot of these different products, and I don't think that it should be lost on everybody in a sport, especially this crowd, it was pretty dramatic when Bell Helicopter changed their name to Bell and their logo became a dragonfly. People are seeing what is happening out there and the revolution that's going to occur. And it's just not aviation, people. Those of you that read the trades can have read that Toyota has partnered with Joby, and Hyundai has partnered with Uber Air to be able to go ahead and start to push this forward, because the automotive companies see tremendous opportunity in this type of mobility. And if you think about the challenge we have collectively to be able to put these aircraft in the airspace, the challenge actually is a 3-dimensional challenge. It's easier than a 2-dimensional challenge. If you're trying to develop an autonomous ground vehicle that has to mix in with cars and trucks that are being driven by humans, You have to be able to anticipate human behavior in certain incidences, people texting on the road, doing all kinds of crazy things, or also people just walking out in the middle of the street, where we have that third dimension. We have that vertical dimension to be able to work with. And even though our speeds are greater, the freedom of movement allows the potential for what we want to do with advanced air mobility to really be absolutely tremendous. So we're excited to have so many of these different designs out there. Battery technology is still a limiting factor. So the committee that we formed is actually called the Electric Propulsion and Innovation Committee, because some of these vehicles will initially have to be hybrid, where we will be burning some type of fossil or sustainable aviation fuel to be able to operate the generators and some of the systems to be able to produce the electrical power. Other ones, we have battery technology, at least that gives us a relatively decent, when you think about the commute time from, let's say, a city center area out to an outlying vertiport, heliport, airport, that we've got the capability to be able to do 1, 2, or 3 flights without a recharge. That's important. Now, one of the companies is depicted on this slide, Alke. They are actually developing hybrids or a hydrogen solution, which the UK has several companies also working on hydrogen. Hydrogen infrastructure is a whole new thing that we've got that a lot of us have been talking about, seeing how viable it is. They actually, in the last 2 days about ICAO in Montreal, they've been talking about and had a very interesting briefing on hydrogen fuels and the ability to use that for any type of civil aviation. So there's a lot happening there. Dan, next slide, please. So Jay Merkel at the FAA had been responsible under Earl Lawrence early on. He cut his chops in the UAS arena, working with Earl. Earl moved over to run all of certification at the FAA. Jay then took responsibility for the unmanned systems, and now in another promotion, I would say, Jay is now in charge of the advanced air mobility segment at the FAA, and we're very glad that we're able to leverage some of his tremendous expertise that he learned on the unmanned side and be able to adapt it as much as possible to be able for the advanced air mobility. I mentioned Toyota and Uber already, so we're excited about the not only automotive companies and others joining into this, but also the large amount of investment that's coming into this part of the industry. I liken it to what it must have been like at the dawn of the jet age. There is tremendous amount of excitement and investment to be able to go in, because the opportunity is absolutely fantastic. Next slide. So what challenges do we have out there? Well, Jim and I were just talking yesterday about the challenges of pilot training and certification. If we stepped out from the get-go, and you think about the type of ops that these aircraft will be operating in, type of 135 type of environment here in the US, if we apply both fixed wing and rotorcraft requirements, we aren't going to have enough pilots out there capability to be able to even man these new types of aircraft. And we don't really need to do that, because these aircraft are all being designed from the get-go to be able to fly autonomously when that capability is allowed to be in the airspace. Up until that time, they will have an operator. Now, some of the operational concepts have an operator on board the aircraft. Some of them have an off-boarded operator, but they will have a dedicated operator with them in the initial phases. But very early on, when we prove the capability and the safety records of these aircraft, who's to say that these vehicles aren't going to be operating with cargo on board at nighttime, so that they can get their utilization rates when in the middle of the night, because they're quiet, when we don't have passengers that need transportation out there. And I think you've seen, those of you watching the trades, you saw electric propulsion all cargo aircraft that Pipistrel, their concept that they're putting forward. And so many companies are also working on the cargo concept. These variable aircraft designs mean that each one is unique. Now, we're talking with the FAA about potentially not having a quote type certificate, but we have a vehicle unique qualification that a pilot would have to be able to operate these each one of these vehicles. So if one pilot went to a different platform, they would need to get unique training to be able to go and be familiar with that platform, because there is quite a disparity and difference in their aircraft designs. The infrastructure readiness is really one of the huge long poles in the tent. When we look at it, especially when I look at the energy grid that's out there and the cost that it takes and the planning cycle, the lengths of planning cycles to be able to dig up concrete or asphalt to be able to lay high capability power generation lines. That's one of the reasons that we're talking about with the FAA and with the EASA of using the current infrastructure that's out there for heliports and reliever airports to be able to go and at least in the initial part of the phases to be able to use that capability, because it's easier to be able to provide that type of power and to be able to install the infrastructure out there. And as you know, in a lot of reliever airports right now in the parts of the US that support it, there is a lot of solar infrastructure going in around airports, Van Nuys, for example. And then you look on the European side, if you go to Schiphol, outside of Amsterdam right now, all of their buses are going to start operating on electric power, and they're going to be able to transmit or be able to use transformers to be able to take that big, huge farm that they're having for electrification and be able to bring it over onto the ramp itself. So there's a lot of excitement, but a lot of work ahead of us to be able to go ahead and work that concept. And then just being able to figure out the multimodal concept of being able to go, how does someone get to the vertiport to be able to transfer? What kind of security requirements are we going to have to be able to be then transported either from tertiary or outlying areas to city centers or vice versa, or into the envelope inside of a airport where they can get on board a larger aircraft? And then merging the different concepts of operations. This is going to be something that we all have to work on very carefully. And again, Jim and I are collaborating on being able to figure out how we can go ahead and work the FAA on this type. Now, there has been a lot of scuttlebutt about looking at NASA's concept, which I think is tremendous, which is called UAT that they've developed for control of unmanned aircraft, basically UAS operating down below 400 feet, and saying, well, that's the holy grail of where we want to go to be able to incorporate these manned advanced air mobility vehicles into the system. And those of us that have been around for long enough know that if we wait for that to happen, it takes too long to change the air traffic control system to be able to enable this type of technology in any reasonable amount of time. So our concepts of ops that our companies are working on are to integrate in the existing air traffic control system. And in my mind, it's all crawl, walk, run. We can safely incorporate in Class B, Class C airspace in the US tubes that actually emanate from down where the Class B goes to the surface out to until we get below the wedding cake and be able to operate then just like other general aviation aircraft do, with see and avoid, using ADS-B technology to be able to spot aircraft, and also have the ability to have controllers give flight following underneath the actual Class B itself, or operate as long as need to in Class B with the tubes that are deconflicted with whatever the approach and arrival path are for the given runway at any day at the commercial airports. So everyone that we're talking to that's in the know at the FAA is very supportive of the crawl, walk, run approach, where we're going to be able to have a capability to operate in the normal air traffic control system. Next slide, Dan. Who is in control will be one of these types of challenges that we will all have to wrestle with together. Again, in the crawl, walk, run, the FAA has come forward with a different phased approach to be able to look at that says that they will be piloted initially, and then piloted when there's passengers on board, and eventually we can move to autonomous. I talked about the interoperability of airspace, plugging. If you look at air traffic management and you plug the ground station into the grid and the network, that would actually be working. Let's say a pilot is on the ground at a ground station being able to operate one or other vehicles. what is the interface going to be with the air traffic control system? And that's something that still needs a lot of work to be done on. And also data communications is important. And I'm not talking about traditional datacom that is now being pushed out to the airlines for en route data management, but also most importantly, it's data communication vehicle to vehicle, because there is going to be a lot of coordination that needs to be done with vehicle to vehicle. And one of the capabilities that we're looking at heavily is the 5G capability out there. And we're very glad that the Congress is being pretty stingy with giving up some of that spectrum within 5G and preserving it for autonomous vehicle operations. That means both ground and air vehicles. But on the air vehicle side, because of the speed that we approach each other at, there's a Doppler shift involved there, and we have to have a little bit more of that spectrum. But we're working hard to be able to develop those concepts to be able to go ahead and move the data communications piece of this forward. Next slide. So that was a quick, very quick briefing. The longer version that I have that I gave it to the FAA regional managers a few weeks ago was about 50 minutes in length and had the neat videos and everything else. But glad to come back anytime and go into more depth on a lot of these discussions. But I think that Leonardo da Vinci had this right when he said many years ago exactly how I know both Jim and I share this passion for aviation, and all of us that are in this industry love it. And that's why it's such an incredibly great industry. And I couldn't be more excited for what we have in store for us. And I know within my career before I retire, we're going to be seeing these aircraft in the system. So with that, Jim and Dan, I'll pass it back to you, but I'll stand by for questions later on.
Yeah, thanks, Pete. That was, I mean, that's certainly in depth of and exciting of the future aircraft that are coming, and Leonardo, captures exactly the feeling I have from the early days of looking up and seeing the aircraft actually getting up and trying to be in as many as possible. So I look forward to the future and some of these aircraft and the different. It's amazing the different technologies that are all coming together. So I'm going to run through a couple slides. You can stay up, and then we can then we'll take some questions at the end. Just kind of doing a reinforcement of almost all the same things that you talked about, Pete. Next slide. So the helicopters originally, we're doing that stuff today. People are out there landing on buildings, they're landing on the side of the roads. I mean, there's so many different mission sets out there that helicopters were, and you talked about some of the transitions like Bell helicopters to Bell. That's one of the things we're certainly wrestling with now as an association. Is helicopter is a vertical lift aircraft, and we want to make sure that we're all inclusive as we go forward, and that the vertical lift capabilities and the unique mission sets and the unique capabilities that we bring to society are captured so that we can work together with the manufacturers as well as the operators, and we've got to bridge some of these gaps that are out there. I mean, certainly the one you were talking about, with the FAA, I think yesterday was a really great story where we were talking about the Garmin Auto Land and just the amount of coordination that it takes to bring on these new capabilities. Next slide. So, these future aircraft aren't going to be going up into the Class A, maybe not even the Class Bravo, as you said. How are you going to work them so they don't have to compete with some of the other aircraft, but actually just have to do what they need to accomplish that special VTOL operation. They can go into confined areas, they can do the low altitude traffic management, and we can use the current heliports as you also expressed. So it's kind of a natural extension, and I'm trying to help the membership here that do these type of operations understand that these are more tools that are coming to the helicopter operators to do different types and different mission sets. And as we work through some of the things you mentioned as well, the certification of these aircraft, now is the time to make sure that we're using their expertise and that we're doing those work groups, we're doing those committees so that we can, as an association, once we come in and I hire the staff to do the association work, we probably are no longer the experts because we're not doing that daily mission any longer. And so we have to reach out and use our members to get that good input. And that's what, I've been trying to do, working out with work groups to make sure we can, whatever gaps are identified, as you mentioned, some of those 6 aircraft that are getting close to flying here in the United States, we want to bridge the gaps, help with the infrastructure, all the work that we do with Gamma to make sure that we can make it as easy as possible and solve those problems for the future operators. Next slide. So as you talked, the optional man, and as you also mentioned, when I was in the FAA and we started to deal with some of these builders of the aircraft, and again, pilot certification, what was that going to look like? And then as you're doing the remotely piloted aircraft, when you get to autonomous, I mean, even the big aircraft, Sikorsky aircraft, are flying autonomously now and optionally piloted. And of course, you got K-MAX, which is doing great work overseas and here in the United States as well. And then once we get through these slides, we'll have a conversation on some of the other thoughts of where we can go and what type of things we can work together on. But the experiences and the best practices is what I'm kind of asking my membership to make sure that they provide, that these aircraft are operating more in the airspace and more in the mission set of the rotorcraft and the helicopters. So I need to get that, we need to be the experts to help these aircraft come on board. Next slide. So what do we need to get ready? You talked about the regulations, not only in the United States, but I like that slide you showed on 7 where it talked about the percentage of aircraft around the world. So you find out that, I think we had it up on stage when we had representative of the AAM and what was coming, is that although they can do experimental work and maybe they can do some of these operations early in other countries, North America, with I think it was 67%, they know that when they make it in North America, then they've made it, for their business plan. So I hope to, once this pandemic is over, to get around and see some of these operations in the other countries so we can help come back and work on North America on how that we can do it safely. The aircraft certification process, when I walked around Heli Expo and I talked to the manufacturers there, everybody's having issues with certification. I think you talked about it with the ASTM standard. I don't think it really came over all the way from the airplane industry. I think we still have some ways to go there, as you mentioned, and so still a lot of work in that area. The infrastructure, charging, refueling, that is what has to succeed for everyone to succeed. The pictures of all these unique aircraft, if we don't have the infrastructure, then it's not going to succeed. Next slide. All right, so with that, Dan, you can just go up to just both of us, but I want to talk about, when we talked yesterday, you talked about some work that had been done already with Gamma. It was I saw the paper on SVO, the Simplified Vehicle Operations. And I was wondering if you could tell us any more about that, or you want to try to explain that. Truthfully, I hadn't seen the SVO wording before.
Well, Jim, when we went initially to the FAA to try to conceptualize what these different companies had in mind, we actually broke it down and said, what right now can the computer do better than the human? And there are certain things out there, navigation, right away. I mean, a computer knows where it is faster than the human mind knows, with all the different capabilities we have out there, whether it's using GPS that we're all familiar with, or LiDAR, or other things like that. It knows where it is. There are quite a few elements that the computer weight and balance, being able to something that shifts dynamically, and that how can a computer adjust control surfaces much faster than the human. I mean, the human, we all paid attention with the Miracle on the Hudson and Sully Sullenberger when talked about the human reaction time. And a computer can do it almost instantaneously when it detects something. And so if you've seen some of these drones that they fail all the engines but one, and it's just coming in, hanging on that one engine, flying in a weird attitude and everything. So there are so many things that we mapped this all out for the FAA and said, okay, as technology goes and develops, what are certain things that we want to have the human in the interface for? Now, one thing a computer is terrible at is predicting human behavior. So let's say you have an emergency on one of these aircraft, and whether it comes down in a parachute or whether it has a different type of landing system, what do you do with panicking passengers? The computer can never figure that one out. And so there are all of these things that go into the hopper. And so working with simplified vehicle operations is a capability to go and see what automation works now that improves safety and what we go and need to direct efforts at. And then how are we going to just implement autonomous or AI?
Right.
And how do you certify it? So if you go and you try to design something and you use AI to go in your certification process that runs a billion different iterations of a scenario, and the computer is doing that, how do you go back and have a human at the FAA verify every one of those scenarios that the computer did in artificial intelligence and being able to find the like gaming solution and everything?
Right.
We haven't even scratched the surface on that. So there is a tremendous amount of work. One thing you said in your remarks that I just wanted to comment on, which I think is something that all of us could really think about this future. I was up at ICAO and I was given a briefing on at that time, urban air mobility. And one of the ICAO ambassadors from Colombia said, well, that's all well and good, and for you rich nation people, this works, but how does it help my villagers out there? And of course, I was trying to think quickly on my feet, and I said, well, what about in your local fire department, your volunteer fire department, that one of these vehicles is sitting there with a pre-programmed pod that takes it to the nearest medical center and lands out there. And all you have to do is put them in a life support pod, hit go, and it gets them there many, many times faster than you would with ground transportation or calling up if they even have any type of medevac in the traditional sense. And he all goes, oh yeah, I get it. And you think about here in the US, how many volunteer fire departments could eventually have something like this that then goes to heliports that we already have established at hospitals in there. So yes, we're just scratching the surface on a capability that I think is exciting and business opportunity for all of us to work on.
You know, absolutely. And that's I mean, I really appreciate your presentation. And when I saw it the first time, it really excited me because those opportunities are out there. I mean, it mixes right in with the training. And the other thing was the, you know, the special operations risk assessment. What freaks out the regulator is that we build an aircraft and then we get all the operators out there to figure out 15 different missions to do with that aircraft that the regulator never had an idea were, but it worries him so much that he wants to try to certify it for every possible thing versus, you know, the flexibility to have the standards like you were talking about, the industry-based standards that says, hey, if I'm using it for this mission, then this is what I got to do. And it doesn't have to be rulemaking. It doesn't have to have a government approval, but the industry has determined that when I build the aircraft and I build it this way, because the flexibilities with these new aircraft, they're, you know, like you talked about, even the ability to fly with one rotor system still working. So you get into whether the guy needs to be a multi-rated pilot to just operate the part that can't be automated. And so I thought that was really good. And I wanted to make sure that, again, everybody that's listening today understands that, you know, there is so much potential to do so many wild and crazy things to help society out there. But we got to get better at what we're currently doing. And that's, you know, some of the discussions we have with ALPA as well, is we got to protect and maintain the current ability to have access to airports and landing areas and heliports. And, you know, we're taking challenges even here in the DC area to try to, you know, if we get all these great vehicles, but I can't operate them inside the SFRA or you can't operate them inside of cities, you know, they don't understand some of the limitations that they could accidentally put on the growth of this industry when they restrict aircraft from operating over the city or some of those areas. But of course, we owe it to them with the safety aspect of it. And I think everybody, you know, I've been working on some stuff here in the last 8 months of looking at all the safety work that's being done in the rotorcraft industry and trying to kind of bring it together so that we don't have duplication. And at the same time, we can focus on the good work that's being done and then where we need to get better with working with the NTSB and other safety boards around the world. So I don't know if you want to add something here, or if we should see if we got some questions.
Well, I think, you know, you brought up so many different points that could be all topics of conversation. But if we look at how these vehicles can be used and capitalize on their being quiet and an ability to use them at hours of operation that don't generate criticism from the public, there's business opportunities there. But one of the biggest things that I think our organizations have to work together along with our brethren at AOPA and MBA and others is we don't want segregation of airspace. And I think we have really pushed, and the unmanned UAS world with the drones initially said, well, we want more airspace, and there's more of us than there are of them, so we want to take over that amount of airspace. And we all were together. We were adamant saying, no, it has to be integration. We have to be able to do that, and we can't allow for segregation that goes and takes away from an opportunity that the freedoms that we currently enjoy flying. And technology is such at a point today, we can safely integrate.
Yes, absolutely. All right, so let's Dan, how are we doing on questions?
We've got a handful of them. I'm going to
Right.
cheat and ask my own question first, because based on the complexity of what you've been talking about, mine's kind of simplistic. But I'm curious because the FAA just granted Amazon approval to begin their delivery system. And so I'm curious how the FAA or an organization like a CAA would use or look at Amazon's delivery process to build out the certification process to carry passengers. Is that even remotely looked at, or are they two entirely separate issues?
Well, Jim, I can start. When Earl Lawrence was back running the unmanned systems, and because he came, if you think about Earl from a standpoint of being at EAA first and working with us on developing all the standards, the consensus standards, and the rewrite of Part 23, and then he went to the FAA and in Kansas City ran the Small Aircraft Directorate. Then they brought him to Washington, and he took over the unmanned systems branch to really develop that. I mean, he was the father that brought it to fruition, and he early on had just a basic spectrum that just showed everything from small drones all the way up to passenger carrying vehicles, and talked about the different levels of rigor and where certification would come into play. So when we designed Part 23, we designed it specifically that if any part of the fuselage or rotor systems as they reticulate and everything, that if they form a wing form, that we could use Part 23 and the consensus standards to be able to certify them and not have to go to special conditions with every single one of these vehicles. That really helps us along. Now, there are forces within the bureaucracy, and Jim knows these better than I do, that they want it to be all rotorcraft, and some folks say no, it should all be special conditions and everything. Right. But we wanted the pathway of least resistance because we already have this set of standards set. So we said, okay, where can we use these current standards, and then where do we have a unique nature to be able to drive them into the airspace faster? In Europe, they're taking a little bit different approach. And we see in Europe, it's going to take longer to be able to go and build this out, especially because we have operational rules for Part 135 in the US, and they don't have an equivalent in Europe. So we want the path to get us in the airspace faster. Where I see some challenges will be later on, how do we validate back and forth between EASA and the US or with Transport Canada if we develop these under different, it's not Part 27, CS27, Part 23, CS23.
Yeah, no, that's the way you worded that, Pete. That was one of the things that kind of concerned me when I was the regulator on the regulator side, was that you see industry and its unintended consequences of industry trying to fit into something because they want to move out, and industry, and that's why when I hear some of my members saying, well, we're waiting on the FAA, I'm like, no, we have to determine what is the best way to do it. We want to do it safely, and we have to help the regulators see why it meets their equivalent level of safety. So a lot of that happens, and then we end up, and I think a lot of it has happened in the rotorcraft community. We were very slow, I think, to move out of the 50s because helicopters, I like to think of them as tools almost, because there's so many different mission sets out there, and that's what really concerns me when the regulator comes out and says all helicopters will. I mean, that just can kill certain segments of the industry. So yeah, working very close, and that's certainly what you do with your association, and I do at mine, is to make sure that we can. What is the path that we need to take? Is it the least resistant? Is it the best path? at this time. And then, of course, internationally, I think we both, where can we go out internationally and help prove concept and then bring it back to the United States. All right, Dan.
Next question is from James McLaughlin. How does design complexity drive certification risk and operating cost?
Well, again, I could start. I mean, the more complex the design is, generally speaking, if you can certify it as a module, it can be very complex if it does a simple solution. So let's take one of the things that we used as a reason to the regulator to be able to go forward with the Part 23 consensus standards, but also with the NORSI, the non-required safety enhancing equipment, which obviously a lot of our rotorcraft move forward with, is if you look at a steam gauge, and it's fairly simple, but then we look at an electronic component that goes on a experimental aircraft, and we can replace it and make it far more reliable with more capability and safer, and its failure rate is so tremendously lower than the steam gauge out there. It's a complex product, but it's cheap. I mean, you look at a standby ADI system now, trying to get an old one repaired versus just buying a EFIS, a system, a low-cost EFIS system. It's ridiculously cheap, and that's so. What the regulator puts on, and if it starts to get take the 737 MAX situation, and we all have been watching this for now a year and a half and everything. When you get to a vehicle of that size and so many different pieces interacting with one another, that's when it's starting to drive cost and time and complexity up. And so there's a direct relationship there. But I think if you can boil it down to the component level, sometimes technology brings along an easier and less costly solution.
Yeah, and with that, I'll just add on, the thing that comes to mind is, number one, you talked about batteries earlier, and imagine today if we were all battery and we wanted to go to gas, and you said you want to load up this flammable liquid in your wings of your aircraft. The regulator would go crazy. How in the world would you do this? Hazardous material, it's flammable. So, I mean, sometimes as during your presentation, you talk about the outdated regs. And that's why sometimes most times I think we need to start with a blank sheet of paper and figure out, hey, what's it, let's get together, get the engineers together. And this is so much safer, or at least equivalent. And normally, as you were talking about, I think of vacuum pumps as well. Getting a vacuum pump out of there that was good for 500 hours, and now you got something that's good for 10,000 hours replacing it, but yet it was a problem, and we had to do NORSI. So,
well, a direct example of that is right now, some things that we're wrestling with the FAA on is drop tests for the batteries itself. So if we look at a drop test on traditional rotorcraft, and this is being driven by some of the old heads in the rotorcraft directory and saying, well, we got to do the same type of drop test. But do you need to do the same type of drop test when you got 6 different rotors moving and you can operate and the vehicle still fly on 2? And oh, by the way, these are completely different batteries, because the way we've had to design a lot of the batteries is to prevent thermal runaway. There's coolant, there's totally different than a conventional looking battery that you see out there today. So it's hard to mix apples and oranges in that same thing. And that's one of the challenges we're wrestling with right now with the FAA, is being able to say, just because we did it that way before, exactly your point you made earlier, Jim, doesn't mean that we can't start off with a clean sheet of paper and say, what do we really need to do to make this safe?
Yep, thanks. All right, Dan.
Next question is from Christian Beard. Can you give your best estimate of the future industry growth over the next 5 to 20 years, both in aviation market segments and total volume of aircraft, excuse me?
Wow. Well, that would have been a whole different answer in January than it is in September. So, I don't know if when the next update. I'm sure a lot of people will be trying to do an update, once a vaccine is developed for the pandemic. But I would be far stretched for me to pull up some numbers right now. It's something, Dan, we can look into and probably email them back.
Not a problem. We have a question from Gregory Lynch that kind of touches back on the question I started with. Would either of you like to address your opinion on the new FAA Part 23 eVTOL versus existing Part 29 certification for electric or hybrid new air vehicles, obviously based on the ability to certify under one or the other?
Well, Pete, if you can help out, I guess I certainly should have brought somebody with the aircraft certification to help me out. Being an ops guy the whole time, that's why I liked hanging out with Earl and always going to Earl with the certification questions. But as you can tell from the questions coming in, and I'd said about Heli Expo in January, certification is an issue for my membership.
Well, I think if you look at the difference, the specific question was the difference between Part 23 and Part 29, which, if we need to look at the size vehicle. So all of these vehicles that we're talking about right now will fit into either a Part 27 or a Part 23 class. Once you start getting into Part 25 or Part 29, you're starting to talk about a big airframe. Even the Aviation aircraft, which I think carries 9 passengers on a regional level, that's a Part 23 type of aircraft. And quite frankly, there's people, even though you see in the trades and all this stuff about clean sheet designs where people are going to carry with an electric regional airliner at any time in the near future, that's just, I look at it with great skepticism, because just knowing how long it takes to certify a product and the current state of electrification out there and our ability to generate power, unless we have some significant breakthroughs being able to have a hydrogen fuel type of aircraft, or we use some type of advanced hybrid in that, we're going to be working in the Part 23 and the Part 27 type of weight categories. And in those cases where we merge those two together, the consensus standard process works well. And I think we have an FAA that understands it. And again, EASA's taken a little bit different approach. You can consider it like special conditions for each one of those, but they're still talking about lighter vehicles.
Thanks, Pete.
Next question is from one of our longtime webinar viewers, Jeremy Parkin. You highlighted the important need for infrastructure to support these new aircraft. What can you tell us about infrastructure planning that might be in place when these aircraft are certified and ready to go?
Well, number one, the infrastructure planning has to be right now. We've got to identify, what are the gaps that will benefit all these different manufacturers for them to operate. As I talked about, making sure that we don't lose any current heliports. And as Pete talked about, the heliports that are out there at the vertiports that are at the hospitals right now. I mean, that was great demonstration that you talked about where, on the training part, if it's fully automated vehicle that the fire department just loads up and launches back to the hospital, I mean, that's great. And then if it's going to be the optionally manned stuff, then that's when we're looking forward to starting the 141 schools out there, starting the making sure that 145 shops are out there that are going to be able to do maintenance on these vehicles. So there's a lot of infrastructure to include training of the operators for these future aircraft.
And I would say that, one example that I use for any aviator out there is how many uncontrolled airfields do we fly into each and every day where rotorcraft and fixed wing are already mixed totally safely. People are advertising where they are in the pattern. We're talking to each other at a controlled airport. It's very safe. So we've got this great package of heliports and reliever airports and over 5,000 airports around the United States that we can have all kinds of capability to install infrastructure there. Now, if we get into cities where we are somewhat limited on the amount of heliports that we have, some of the concepts that have been thrown out there, Uber has thrown out the concept, will there be a parking garage with a platform on top that goes and not only accepts these vehicles, but also has a recharging capability? And is that going to take longer to build that recharging capability there, or have the capability out in suburbs where it's easier to go and again, dig up concrete or asphalt or turf and everything to install the lines in that? So that's a question. But the other thing we've gone to the FAA to ask for is help us establish some standards if we're going to produce those, that may be, again, a different way of looking at it than a traditional heliport because of the noise and vibration signature. We will be significantly reduced noise, but there's some vibration components and resonance that's involved in all of those electric motors turning and everything. And we need to put some rigor and science into that, because we don't want the general public to be annoyed because their china is rattling in the cabin or something like that. And so how we do this from the get-go will be important. And that's why collaboration with you guys, I think, is extremely important, of knowing what are our lessons learned with the heliports, and how can we then adapt that to having the FAA help us with the vertiport concept as we flesh it out.
And we actually have a Fly Neighborly working group that is working on just that. So thanks, Pete.
Question from Carlos Schillinger. How is the FAA doing with the concept of Operation ConOps 1.0? They mentioned that it might be independent of the regular airspace classes.
You're talking about something I'm not familiar with enough to talk on 1.0.
Okay, not a problem.
Well,
go ahead,
I
Pete.
would just say that
Integration is what we were looking for.
Yeah, the question kind of leads to the segregation question, which I don't think anybody in the FAA leadership or in industry leadership says that's suitable. It is a crawl, walk, run type of scenario. And quite frankly, we want to get these vehicles out from down and below 400 feet as quickly as possible, especially if you're thinking in an urban area where you may have a lot of unmanned systems delivering packages or doing whatever. We want to get them higher up, safe, and integrate them into the airspace out there. But if you have in a tube, again, a tube concept running through there, and you have a human that can go and interface with air traffic control, but also the air traffic controllers just see a conga line in a tube going through there, it's not going to overwhelm their scopes if this tube is operating with multiple vehicles in this conga line going in that specific tube. So I think it's very doable in the near and midterm, before we arrive at this fully all the vehicles talking to one another and all networked and doing their own self separation. That's not going to happen for a long time.
Gentlemen, we are right up against our normal stop time. Are you allowed? Do you have time to continue a little bit longer?
Sure.
Okay.
Sure.
We have a question from Gene Munson. Are crash-worthy requirements for Parts 27 eVTOL being strictly adhered to, or will exceptions be allowed structurally and for living space preservation? And Gene is another one who's been on many of our webinars.
We have looked specifically and have standards established for structures. Again, if you're certifying this aircraft and you're able, whether you're using Part 23 or some special adaptation to that, there is a lot more capability to look at crashworthiness from one, does it have a parachute? Does it have crumple zones? Does it have airbags capability? And so we were given more freedom to be able to work with crashworthiness, to be able to leverage and think differently. And we learned a lot from NASCAR. You hit a wall in a NASCAR and you can take a 30 G hit, and all of a sudden the driver can be popping out and waving to the crowd right away. And it was in how they stabilize the body and the crumple zones on the aircraft. So we're really encouraged that on the structural side, that the FAA and EASA are looking at it from, how do we keep the occupants inside safe? How many years have we put effort into how many G's that the seat can handle when we know the human body that's in the seat is not going to be able to survive that. But boy, the seat will stay there. And so there again, as Jim, as you mentioned earlier, I think there is consensus that if we look at this in a different way, we can keep the occupants safer.
We have a question from Mark Colburn, and Mark is on the, he is a member of the HAI UAS working group, so we appreciate his attendance and his efforts on behalf of the industry. Mark asks, Amazon received a Part 135 exemption for their operation. However, in order to fly their delivery drones outside the test areas, will they need to TC their aircraft?
I know that there's I saw some of the stuff that Wing got approved when they were doing deliveries down by Charlottesville. I don't know specifically, but it's probably online exactly what they have, because it's got to be public viewing.
Yeah, and I think that where a traditional type certification kicks in is, again, I don't follow the unmanned aerial systems as closely as I do the manned systems. So I don't know where actually that threshold is where they actually call it a type certificate. They're certificated, but where actually the word type certificate comes in, I don't know.
Yeah, if it can't fall under 107, then it's going to require something special.
Okay, we have a question from Chris Soldo. He actually had a couple of them. We're having to break them down because we do have a handful of questions we want to get to. What initiatives are being done to change the public's perception of safety for air taxis? These unmanned aerial vehicle OEMs have to meet a tough standards for safety certification.
Oh, absolutely. I mean, that I think nowadays with I think we had Bella here on our on a webinar where they talk about all the computers able to run through all the different scenarios and the work that's being done with all the test vehicles. I mean, with all the safety teams around the world, it's zero fatalities is what we want in industry, and we keep working towards that. So we're not going to allow a new vehicle to come on with any risk to the people on board.
And the manufacturers of these vehicles have all gotten together and they've actually formulated a organization to actually talk about and talk to the public on the perception of these vehicles and try to get ahead of it instead of trying to go and introduce the vehicles and trying to explain things to them, is actually just tell folks what to expect and what the safety capability are of the vehicles. And then I've heard, as far as people riding on the vehicles, I've heard a lot of people say, well, I'll never get into a pilotless type of aircraft. And they're generally my age, where I talk to young people and I talk to my kids and they go, huh, computers fly safely and everything like that. And I doubt if they'll look up from their iPhones long enough to be able to look and see if there's anybody in that front seat. But I think, some of the concepts of some of these operators, actually you'll be talking to an operator, especially maybe in some tour type of operations early on, where you're actually communicating real time, but that operator isn't sitting in front of you. Where some of the other vehicles, they'll have the operator sitting up front and you can have a conversation with the person because there'll be one seat right in the center looking in the windscreen.
No, exactly, Pete. And I think that the example I always use is the elevators. Back when they had the elevator operator, you walked in, you told him where you're going, he drove you. Can you imagine the first time that the doors opened and nobody was in there? I bet there's a lot of people that decide to take the stairs.
Yep.
We have a question from Rex Alexander, who is an HAI member. He is also doing some great work with the US HST Infrastructure Special Emphasis Area, which we appreciate. Do you see Part 23 aircraft being required to meet Part 27 helicopter handling and controllability standards for landing at heliports and vertiports, especially those located on rooftops?
I was going to say, I hope not. I mean, I think the capability, that's one of the things that when I was with the FAA, I was still working on, and I think we talked about it a little bit with the simplified vertical operations, is that the computer can do such a better job. And they've demonstrated with some of these vehicles. So there's still the risk analysis has to be done, but I think when you're limiting the technical abilities of the vehicle to the human's capability is what I saw as kind of holding back some of these vehicles.
I flew one of the simulators about 6 months ago on one of the vehicles that's probably furthest along. And basically it was the simplest thing I have ever done. You basically put the machine over where you want, you hit a button, and no matter what the wind is, no matter what's happening, and you can actually see with your sensors, you can see the big H, and you can put it down right smack dab in the middle of, because you're just over it, and you point it. If you want to make a little bit of input, it's just simple. I don't think that there's anything as easy to fly as what one of these vehicles will have. So I'm sure when our FAA test pilots get in there, they'll run it through all the different failure modes and everything like that. But as you said, Jim, the computer, there's so many different surfaces working. The blades within the actual engine are moving. The engines are moving. They aren't, the aircraft doesn't fly like a traditional aircraft where, you have, it may just it may rotate this way versus doing a smooth turn like a fixed wing aircraft does and everything. So you're mixing in a lot of the rotorcraft and the fixed wing side, and it's amalgamation, but the computer is just making it seamless.
Yeah, no, I was on in a simulator as well, and it was a helicopter simulator, but they didn't have a cyclic. Well, actually, on the one I was in had a cyclic, and I said, well, if we're going to be doing all these maneuvers, it'd be a lot easier if I just had kind of a side stick or even a mouse to roll to. I want to take off and go to 80 knots. I can just roll to 80 knots, and the helicopter does its thing, rolls out to 80 knots, does a nice, stays at 80 knots. I mean, it just basically, how do you transmit what you're trying to do to the equipment versus keep anything, it's the evolution versus, again, starting with a clean sheet of paper. What are you trying to get it to do? Vertical takeoff, vertical landing. What's the best way to do that? Is it a cyclic? Probably not. So I love seeing all the, like you showed early on, and I think it was slide 9, all the different versions of aircraft that all have that vertical takeoff and landing. And it's just the imagination now of getting them certified and then getting them put into all the mission sets that are out there.
I think let's just take one more question. I appreciate the time you gentlemen have given us today. Do you anticipate any of the more agile development processes common in the high-tech or advanced air mobility industries could transfer over to the traditional manned aircraft development and certification processes? Can a learning curve ever be realized?
I am the eternal optimist, and I would say yes. Quite frankly, I think it's probably good that we didn't move out on Part 27 to mimic Part 23 in retrospect right now, because we are still having a challenge with folks out in the field, the engineers out in the field, understanding how totally to utilize the standards that are out there. In fact, and a tribute to Administrator Dixon and Deputy Administrator Elwell and our general counsel at the FAA and Ali Barami and the head of safety, that we had a conference with them about a month ago where we said we're having some problems with getting the standards adopted and blessed so that they're universally available out there. And that is causing a delay in the FAA workforce being able to accept a company using those standards. And so it's education of the workforce, but it's also getting FAA legal and others to be able to say, yes, FAA personnel participated in the standard development with SION structures, and this is now an internationally accepted standard, and company X, you're allowed to use that, show compliance, okay, the box is checked. We've still got to get this right on the Part 23 side. Then I think that it will be ready then to move over to traditional Part 27.
Well, thanks, Pete, and thanks everyone for asking the great questions. Again, it tells me that certification continues to be pretty high up on the priority for things that I need to help with, and I'm going to reach out to Pete and others and other associations to make sure that we're working on behalf of the members of HII to make sure we're ready. And again, the operators out there that are going to operate these vehicles of the future, think about what you have to do to be able to maintain them, to operate them, training, and then pass those along to us, to me, president@rotor.org, and we'll make sure we got a list of how we're going to help get these vehicles out there and help society even more with the vertical lift capability. Any closing comments, Pete?
No, a pleasure to be with you. And as I said, we love the team at HAI. We're doing a lot of coordination. There's some legislations, rotorcraft specific legislation that our government affairs teams are working hard together with. And I'm excited that you and I are in lockstep with being able to talk about, let's not be traditional looking, and this is on the flight data recorder issue, and how can we go and help the collective, help all aircraft be able to explore modern technology on flight monitoring to be able to prevent the next accident, not do forensic analysis on the accident that just happened. And we can do this with modern technology. And I think having our teams working together, we'll be able to win the day on that legislation and convince the folks up on Capitol Hill that we can do more than just mandate certain things for certain types of rotorcraft out there and really move the safety needle.
Thanks, Pete. Absolutely wonderful working with your team as well. Over to you, Dan.
You're on mute, Dan.
Thank you both, gentlemen. I really appreciate your time this afternoon. I think this really goes to show how collaboration can improve our industry in so many different ways. We talk about collaboration through safety, but this is an entirely different area. It's looking into the future, and you've really just made it that much more powerful for all of us. So thank you for your time.
Thanks.
Thank you.
We want to address a couple of housekeeping issues. We do have a questionnaire that will be coming up very shortly. We do ask you to take a few moments to respond to the questionnaire. Many of our subject areas for our webinars come from your suggestions. We do appreciate them. Save the date, next week, September 10th, we have HAI at Work webinar. If you could see what we have seen, an aviation accident investigator's perspectives. It's going to be gripping. Let's just put it that way. What can you learn from what they have seen? That'll be at 4 p.m. Eastern time, same as we normally hold our webinars. Watch for the link in email, through social media, and through Rotor Daily. Jim mentioned this a minute ago. If you please have any comments for HAI, what we could do better, how we could help collaborate with different projects aside from advanced air mobility, we are always looking for ways to assist our membership. Please contact Jim at president@rotor.org. He sees every email and he distributes the email to the staff where it's appropriate, and we do our best to help our members. Until next week.
Dan, just a correction on the date. It's the 17th.
17th, excuse me. I missed one date on my time. I do appreciate that correction. Thank you. Until next week, we do ask that you stay safe, that you fly safe, and we will see you next week.